Mr. Williams? All right, baseball leaves the bat with an initial speed of 30 meters per second and clears a fence 90.5 meters away. The height of the fence is the same height as the initial height of the batted ball. If the distance of the ball traveled is given by that equation, where 9.8 is in meters per second squared, find the interval of possible launch angles of the ball in degrees. Well, we have a formula. So we have this formula, and so they want us to solve. Gee, does anybody know why we have this story problem in this section? What does it have in it? Sine of theta. What do you know how to solve for? You know how to solve for theta. So that's why this story problem is here. Other than that, it's not unlike any other science or math problem that you might see on a test where they give you a formula and you're just supposed to manipulate the formula to find the answer. You already know some of the numbers. What am I plugging in for D?
90.5.
90.5, because that's the meters away. What am I plugging in for V sub 0? What is V sub 0? Many of you guys have physics, right?
Initial speed.
Initial speed, initial velocity. So the initial speed, the initial velocity is 30 meters per second. I'm just going to plug in the 30, but I have to be careful because it is squared, so I have to make sure to square that number. Times sine of 2 theta. The 2 theta is inside the sine, and it's over 9.8. So when you get to story problems that have a formula, sometimes it involves more than just the formula, but right now we're just going to, sometimes it involves more than the formula, but right now we're just going to plug it in, plug stuff in and solve. So how am I going to solve for, it's like having x squared, right? You got to get that term by itself first. What am I going to do first? Multiply by 9.8. So we're going to multiply both sides by 9.8 to clear that denominator. We got 90.5 times 9.8 gives me 886.9. This gives me 30 squared, which is 900 times sine of 2 theta. Next to solve, I'm going to divide by 900. That's not going to work out to be pretty, and I do not want to round it because I could get a rounding error, especially when I have a function involved, not just division or something. So I'm going to leave it like this for now. Sine of 2 theta equals 886.9 over 900. Is that on our unit circle? No. So I can't use my unit circle, right? And when I'm evaluating this, at least within one rotation, right? There's going to be 2 answers that have a positive output for the value of sine. What quadrants will those be in? Since sine is positive, it's going to be in quadrants 1 and 2. If it was cosine, it would be 1 and 4. So, and if it was tangent, it would be 1 and 3. So I know there's 2 answers, but I can't get them off my unit circle. But my calculator could give me one of those answers. To make it map so that it was actually a function, we had done arc sine. We restricted the domain of sine so we could generate arc sine. And what was the domain restricted to? Does anyone remember? The domain was restricted to negative pi over 2 to pi over 2 for both sine and for tangent. So when I do this, it's going to give me an angle somewhere in quadrants 1 or 4. But that's not the only place I have an answer, right? What other quadrant do I have an answer in? In quadrant 2, and we're going to have to figure that out in a second. So if it's not on the unit circle, you know, if it's cosine, it's going to give you between 0 and pi, but there's still an answer if it's positive down here, if it's negative down here. If it's tangent, it's going to do the same as sine. It's going to give you one answer between negative pi over 2 and pi over 2, but you still have to find the other one over that one rotation. So right now I'm going to use the calculator. I'm going to do sine inverse. Sine inverse of 886.9 divided by, and it says to do it in degrees. So I better make sure my calculator is in degrees. Most of the time in pre-calc and higher levels we use radians unless the problem calls for degrees or it started out as degrees. So for this one, we have 886 over 900. And that gives us 80.2 degrees, or roughly 80 degrees. I'll just do 80.2. And that's our answer in quadrant 1. We have 80.2 degrees. Do what? Yeah, so that's what 2 theta equals. So that's not quite our answer yet. That's what is equal to 2 theta. So yes, in terms of theta itself, I'd do 80.2 divided by 2, which would be 40.1. But we have another theta, or possibly a range between these, between 40 and something else, between when it's 2 theta, 80.2 and something else. So how do I find that? If I know the angle, and it's in quadrant 1, and it's 80.2 degrees, and I know the other one's over here, how do I find that? Well, I could go back to my reference angles, right?
Is it the same?
Normally, it's not always the same, so I have to be careful, but yes, it's the same idea, right? If I know theta, or theta prime, the reference angle, which in this case is our 80.2 degrees. Okay, I'm getting tired of the pen not working.
Wait, Mr.
Yes.
Is it 40.1?
Is it what?
40.1.
Well, we evaluated it first, and then we divided by 2. So in order to find this other one, this is what 2 theta is equal. I got to figure out what else is equal to 2 theta. So I'm going off of the 80.2. So yes, I said theta, but I meant 2 theta, sorry. So you have to solve for theta afterwards. When I'm evaluating this, trying to figure out what value would be equal to this, what other value. So this is our reference angle. Remember that in quadrant 2, it's 180 minus the actual angle. Well, I don't have the actual angle, I have the reference angle. I could change this equation, now what would I do to move this over here? Add it. And what would I do to move this to the other side? Subtract it. So for this quadrant, it does work out to be 180 minus the angle. So 180 minus 80.2 is 99.8. But that's equal to 2 theta, so I have to take the 99.8 and divide by 2. Which I'm going to do that here. It's not working. What is it? 49 point, thank you, 49.9. So there are my 2 answers. And arguably, if one's on the minimum end and one's on the maximum end of where he could have hit that for it to meet the parameters of the problem, it could be anywhere within the range of 40.1 degrees to 49.9 degrees to get that out. But those are the exact values that work for this equation. All right. Any questions on that problem? So it's just like yesterday. I mean, yeah, there's a word problem involved, but it's just like yesterday in terms of plug. Once you have your equation, just solve for sine. Find out what angles give you that for sine, and then because it's 2 theta, divide those by 2. Any questions on that? All right, Pythagorean identities. Who can tell me one of the Pythagorean identities that involves sine and cosine? Sine squared and cosine squared equal 1 when you add them. Yeah, not working. Guys, I'm trying to record, and the background noise is really pissing me off right now. So please, if you have a question, ask. Otherwise, don't talk. There's people who aren't here that want it. Sine squared plus cosine squared equals 1. Yep, still not working. What else? What is the one in terms of secant or?
Oh, secant squared, minus
Plus
minus tan squared, minus tangent squared. Cosecant squared.
Minus tangent squared equals 1.
Cotangent squared, no.
Cosecant squared minus tangent squared plus 1.
Cosecant
Oh,
squared
man.
minus cotangent.
So I haven't graded those yet, but I'm a little worried now. Hold on, yeah. 1 plus tangent squared equals secant squared, right? 1 plus tangent squared
There we go.
equals secant squared. Now that's okay because some of you just gave me a variation. You said secant squared minus 1 is tangent. That's the same thing. Yeah, that works.
Do you want all of
All right. I know. I just want another one in terms of cosecant. 1 plus cotangent squared equals cosecant squared. So all those identities that we needed to do trig proofs, we can use to solve equations if we don't have an equation. All the problems you did yesterday, you could like get it down to one trig function. Sometimes you had to take the square root, or you could factor it, and maybe there's two trig functions that they were factorable. It worked out that inside each factor there was only one trig function. This one, not going to work out that way, right? In fact, if I go to solve this, I'm going to move this stuff over here by adding and subtracting the one. I've got 2 sine squared x plus cosine x minus 1, and that's equal to 0. I can't factor that. I can't factor out a sine or a cosine and get it to one trig function, or even get it to each factor having its own thing. But I can rewrite it using the trig identities, in this case the Pythagorean identities. I can write this as 2 times 1 minus cosine squared plus cosine x minus 1. And now everything will be in terms of cosine, so I should be able to factor it, hopefully. So this is 2 minus 2 cosine squared. Shoot, I should have done the other side. Oh well. We can always change the signs.
Should that be a sine squared?
No.
Cosine squared?
It was a sine squared. By using the Pythagorean identity, I've just made that 1 minus cosine squared. So that I can get everything in terms of one trig function. So now the 2 minus 1 is that right? Yeah, is 1. And I have negative 2 cosine squared x plus cosine x plus 1, because I have my 2 and my minus 1. I don't like working with the lead coefficient being negative, and since it's equal to 0, I could just divide everything by negative 1. Divide by numbers, can't divide by functions or by x. I could do that, and that would make this one negative and make this one negative also. So that makes it easier for me to factor. So now I've got 2 cosine times cosine, which gives me the 2 cosine squared. I've got 1 and 1. I need a negative in the middle, so I need the 2 to become negative, so that's going to be the negative sign, this will be the positive sign. And these are both equal to 0. So what that's going to do is that's going to give me, this one's going to give me cosine of x equals, I'm going to subtract 1 and divide by 2, so negative 1/2. This factor right here, if I have it equal to 0, is going to just be cosine equals 1. Cosine of x equals 1. And those are on the unit circle, so we can evaluate them using the unit circle. Cosine is negative 1/2 at, 2 pi over 3 and 4 pi over 3. And cosine is 1 at 0. So there's only 3 answers for this one. Try letter B first, but do me a favor, try to get everything in terms of cotangent. Try to get everything in terms of cotangent. You're voting for Ratner. So some of you found a quicker way. It's not what most people choose, and I'll talk about that in a second. What I would have done, I would have changed them both to, and what some people did that I saw earlier, some of you even now, you just change this to cotangent squared times 1 minus cotangent squared plus 2 times, is that right? No, it's 1 plus, sorry. 2 times 1 plus cotangent squared minus cotangent squared. I'll show you the quicker way in a second. But that's what a lot of people did. Equals 2. Thank you. So I will have to take away the 2 in a second. Yeah, thank you. I didn't see there's 2 over there. All right, so when I distribute this, this is, no, cancel. That was our page, right?
Yeah.
There it is. All right. So this becomes cotangent squared plus cotangent to the fourth plus 2. Is that 2? Yes, plus 2 plus 2 cotangent squared minus cotangent squared. Well, here's a negative cotangent squared and a positive cotangent squared. So those are gone. And then if I get this equal to 0 by subtracting that 2, the 2's cancel. And I'm left with cotangent to the fourth plus 2 cotangent squared. Now, Kim, and I've seen other people do this too, said, well, really, this is, well, no, the 2's not times that, though, so I don't know if that
No,
works.
you can just grab, it's still working.
Oh, you just
I
do
still
it
have
as,
the same answer.
oh, you just did cosecant plus, no, it's squared, though, yeah.
It's because the cosecant squared minus the cotangent squared is 1, so 2 times 1 is 2, minus 2.
Yeah, but the,
It's not going to both.
yeah, but you can't, that's basically what you're doing,
I
though.
got the same answer though.
Okay, I'm not sure how. Well, look, all right. So here, let's look at this. This I can factor out cotangent squared. That's going to give me cotangent squared plus 2. How many of you got that? Good. Some of you have tried it. So now I have cotangent squared equals 0, which, if you know how to get cotangent squared, you all know it's cosine over cosine. I'm going to take the square root of 0. Square root of 0 is 0. So cotangent of x is 0. You can do cosine over sine to get that, or you could flip it. If you're going to evaluate it in terms of tangent, it would be undefined, whereas tangent undefined. Tangent's undefined at pi over 2 and 3 pi over 2. Cotangent of x is 0 at pi over 2 and 3 pi over 2. And then cotangent squared plus 2, if you set it equal, then you get cotangent squared equals negative 2 when you take away the 2 from the 0. And you take the square root plus or minus I square roots of 2. So there's no solution for that portion. Any questions on that? All right, so if I have it in terms of 2 trig functions, and I see a squared, and it's not factoring out nicely, then I'm going to see if I can use a trig identity, the Pythagorean identity in particular, to get it in terms of 1 trig function. If it factors like the ones yesterday, do that. It's easier if you can just get it to simplify like yesterday's practice problems. For 6a, we don't have anything squared though. So we have a little bit of a problem. But not too bad, because I could just square both sides. It's okay, if you're going to square one side though, you have to square the entire other side. And in doing that, I've got secant x plus 1 times secant x plus 1 equals tangent squared. And over here, this is secant squared plus 2 secant plus 1 equals tangent squared. So which trig function should I work with now? Secant. I don't want to change this to 1 minus tangent squared because I still have a secant in there. Do you have a question?
Tangent squared equals.
So now tangent squared is secant squared minus 1. I probably wouldn't work in terms of cosine until the very end, because otherwise you're going to be dealing with fractions. So now I'm going to subtract secant squared. Yay, they disappear. I'm going to add 1 to both sides. So now I've got 2 secant plus 1 equals 0. I'm going to subtract 1 and divide by 2. Is that right? Yeah. Secant of x equals negative 1 over 2. Was it plus 2? Why is it plus 2?
You added 1 plus 1.
Oh, thank you. Duh. I'm like, wait a minute, this one wouldn't have a solution. because cosine can't equal -2. So this is -2/2. Now it will have a solution. Thank you. Equals secant of x equals -1. If you don't want to think about it in terms of secant, think about it in terms of cosine. By flipping this -1/1, it becomes 1 over -1. It's still -1. And cosine is -1 at pi. Had we had, which we don't for this, I just want to point this out, had it been secant x equals -1/2, that would have meant that cosine of x would be -2. Is that on your unit circle? Is your calculator going to do it? What is the range on cosine? It's restricted to from -1 to +1. -1 to +1. In terms of the outputs for cosine. Unless you do a vertical stretch or something to it, but that's different in terms of actually evaluating the angle. It has to go between -1 and 0. Try the next problem. Try the next problem. So if you got this, then you're on the right track, because you can't really factor out a cosine when there's no cosine against the sine. And you can't change them using any identities unless you want to deal with, well, even then it's not going to work. So you need to square both sides. So you square both sides, and then I'm going to change, which function should I use? Sine. So this is 1 minus sine squared. I'm going to subtract the 1. I'm going to add the sine squared. So I have 0 equals 2 sine squared minus 2 sine. And you're going to factor out how much? 2 sine. 2 sine of x times sine minus 1. Set them both equal to 0. This one's going to give you sine of x equals 0, because you're going to divide by 2 and still have 0. This one, you're going to have sine minus 1 equals 0, so you get sine of x equals +1. Sine is 0 at 0 and pi. And sine is 1 at pi over 2. So there's our answers for those. Any questions on those? All right, so you're going to work on the assignment that goes along with this is, that's on here, but I don't know where. Page 331, 19 to 30. And you have some time today to get started in class, or see me if you have individual questions from last night's problem.